In today's video on Azure Compute and Networking Services, we will discuss application hosting options and explore the dynamic landscape of Azure Web Apps, containers, and virtual machines. The goal of this video is to narrate the Microsoft Learn content, demystify these concepts, add additional information when needed, making concepts easier to comprehend. You can follow along on the Microsoft Learn page. A triangle with MS in the center shows the page number of the Microsoft Learn unit. This video is the second video in the lesson starting at Unit 5. Feel free to check out the first video, Create a Virtual Machine, Scale Set, and Understand Virtual Desktops, or the playlist called Understand How to Describe Microsoft Azure Architecture and Services, in this Azure Fundamentals learning path for more information related to Azure Fundamentals. The goal of this video is to describe application hosting options, including Azure Web App containers, and understand the differences between virtual machines and containers. Describe Azure containers. Virtual machines are an excellent way to reduce costs versus the investment necessary for physical hardware. They're still limited to a single operating system per virtual machine. If you want to run multiple instances of an application on a single host machine, containers are an excellent choice. Why containers? Containers are a virtualization environment, similar to running multiple virtual machines on a single physical host. You can run multiple containers on a single physical or virtual host. Unlike virtual machines, you don't manage the operating system for a container. Virtual machines are an operating system you can connect to and manage. Containers are lightweight and designed to be created, scaled out, and stopped dynamically. It's possible to create and deploy virtual machines as application demand increases, but containers are a lighter weight, more agile method. Containers allow you to respond to changes on demand. With containers, you can quickly restart if there's a crash or hardware interruption. One of the most popular containers engines is Docker, and Azure supports Docker. The following video from Microsoft highlights several of the important differences between virtual machines and containers.
In this video, we'll discuss the difference between virtual machines and containers. So let's begin. Deploying server applications has always been complicated. That complexity drove system admins to start looking at virtualization techniques like virtual machines and containers. Virtual machines, or VMs, provide an abstraction layer for CPU, memory, and storage. They can be changed without having to invest in new hardware, while still allowing the environment to be flexible and secure. With VMs, you're in control. You decide the operating system, install tools and packages, and your app runs either in isolation or with the other apps you install into the VM. But there are downsides. VMs can only run one operating system at a time. So if you have multiple server apps that all require different runtime environments, they may also require multiple virtual machines to execute properly. And because the VM is emulating a full computer, tasks like starting one up or taking a snapshot are pretty slow, often taking several minutes. But there's a lighter weight solution that solves some of these issues: containers. A container bundles a single app and its dependencies, referred to as containerizing the app, then deploys it as a unit to a container host. The container host provides a standardized runtime environment which abstracts away the operating system and infrastructure requirements, allowing the containerized application to run side by side with other containerized apps. An easy way to differentiate between VMs and containers is virtual machines virtualize the hardware, while containers virtualize the operating system. The operating system level virtualization of containers is one reason why the container approach is more efficient than a full virtual machine. It allows you to run multiple lightweight containers on a single host without sacrificing the isolation that the virtual machine originally offered. Azure supports several container variations, the most popular being Docker. Unlike VMs, you can spin up containers quickly. You're just waiting for the app to launch instead of both the operating system and the app. Also, containerized apps tend to be much smaller in size, and the development process is simplified because your development runtime environment can look exactly like the production environment. Another advantage to containers is that they can be orchestrated with container cluster orchestration. You can easily deploy and manage multiple containerized applications without worrying about which server will host each container. The decision of whether to use a VM or container depends on how much flexibility you need. If you need to completely control the environment, then you might choose a VM. If not, then the portability, performance characteristics, and management capabilities of containers might be the better choice.
Azure Container Instances offer the fastest and most straightforward way to run a container in Azure without having to manage any virtual machines or adopt any additional services. Azure Container Instances is a platform as a service offering. Azure Container Instances allows you to upload containers and then the service will run the containers for you. Azure Container Instances is a service provided by Microsoft Azure that allows you to run Docker containers without needing to manage the underlying infrastructure. Azure Container Instances, abbreviated ACI, provides a simplified way to deploy and run containers in the cloud. With ACI, you can quickly spin up individual containers or groups of containers, and Azure takes care of the provisioning, scaling, and maintenance of the infrastructure. Azure Container Instances offers a serverless container runtime, meaning you only pay for the compute resources you consume. There is no need to manage virtual machines or other infrastructure components. ACI is suitable for scenarios where you want to run individual containers or short-lived batch jobs without a complete orchestration platform like Kubernetes. You can deploy containers in Azure Container Instances using the Azure Portal, Azure CLI, Azure PowerShell, or through code using the Azure SDK or API. Azure Container Instances integrates with other Azure services like Azure Storage, Azure Networking, and Azure Monitoring. Azure Container Instances can achieve quick and on-demand container deployments while abstracting away the underlying infrastructure, management, and scaling aspects. Have you ever wondered how apps are created and managed? Azure Container Apps is one of the technologies that lets you do just that. It's like having your virtual toolbox to package and deploy your apps quickly. With Azure Container Apps, you can learn to build and run your applications in a fun and exciting way. Imagine creating your games, productivity tools, or even chatbots. Azure Container Apps are similar in many ways to a container instance. They are both platform as a service, PaaS, and allows you to get up and running immediately. Container apps have extra benefits, such as the ability to incorporate the load balancing and scaling. These other functions allow you to be more elastic in your design. Azure Kubernetes Service, abbreviated AKS, is a container orchestration service. An orchestration service manages the lifecycle of containers. When deploying a fleet of containers, AKS can make fleet management more straightforward and efficient. Imagine you have a bunch of containers, like a food container, containing everything an application needs to run smoothly. However, managing many containers can be tricky, just like organizing a large kitchen. That's where Kubernetes comes in. It's like a master organizer for your containers. It helps you manage and control all these containers, making sure they run smoothly and work together harmoniously. Your cooked noodles and pasta sauce are in one container, and sausage and eggs are in another container. Each container makes a meal. Kubernetes assigns containers to various resources, ensuring each container has the necessary resources. It also monitors the containers, ensuring they stay healthy and start up again if anything goes wrong. It can even scale up or down the number of containers based on demand. If you are having a football party, you may need more containers. If it's just you, you may need fewer containers. In simpler terms, Kubernetes is like a manager for your containers. It ensures they are in the right place, doing the right thing, working together to create unique applications. Containers create solutions by using a microservice architecture. The architecture is where you break solutions into smaller independent pieces. For example, you might split a website into a container hosting for your front end, and another hosting your back end, and a third for storage. This split allows you to separate portions of your app into logical sections that can be maintained, scaled, or updated independently. In this module, you learned about containers, learned about Azure Kubernetes Service, and compared containers to virtual machines. And I'd like to thank you for watching.